Okay, cool. From what I can tell on my end, let's see here. Yeah, from what I can tell on my end, it looks like everything's up and running. I'm not sure what happened there. Occasionally, I've had like some odd. Okay, cool. I just got word from somebody that the signal seems much better. Okay, great. Occasionally, I start stream and something like during startup just gets weird, and I've had a, a variety of just odd issues and crashes, but that's not usually the case. But yeah, looks like we're up and running again. Thanks for everybody's patience. And sorry for the delay. Usually I do try to get us started on time, but it's a little bit of a hectic day for me. Excuse me. Sorry. It's a little bit of a hectic day for me, and I just wanted to, just needed a little time to finish something up before we started today. So, as usual, welcome to Study Hall. This is, if you're new here, this is a forum for you all to ask questions. And if you have questions, especially with Galvanize material, the Galvanize Learn material from Basic Prep, you're welcome to bring those in. Um, you're welcome to bring in a question. So far as I'm concerned, you're welcome to bring in a question from anywhere. We can cover a concept that you want to cover. We can go over if you have some code that maybe works, you don't understand why, and you want me to explain something about it, or doesn't work and you don't understand why, and you want me to troubleshoot it and explain how I would get it working. Yeah, so anything you want to talk about, feel free to just post it in the chat. Anything Python related that you want to cover, post it in the chat. If it's a problem from somewhere on Learn or whatever, please just include a link, and I will get to it as soon as I can. Yeah, that helps me answer it quickly. Cool. All right. So without further ado, we kind of have a little bit of a choice here. I've been kind of debating this whether to go through the importing, continue with the importing in the math module from Learn, or to do another Code Wars, another couple Code Wars challenges. So right now, well, right now I'm a little torn on what to do, but um, yeah, I think maybe I'll do a couple. We'll start off with a couple Code Wars problems, and jump into the math module a little more when we do a couple of these. Also, I'm just going through these since I don't see any questions in chat right now. Yeah, the main purpose of this is really just for you all to bring in your questions. But since I'm not seeing anything, I'll just kind of cover some other topics, and yeah, we'll just go from there. Cool. So let's jump in. Let's do a couple Code Wars problems. So I've done a couple of these Code Wars streams before. I think we're just kind of getting a new cohort started, and we've got some people who might be new in here with us, so who might be watching. So I'm going to cover kind of the basics again of like how to get up and running if you haven't used Code Wars before. So so this is Code Wars. What you're looking at here. This is one of the mini sites, and it's sort of just the one we default to when people ask us if we have other good resources for just like doing practice problems. I think our material is really good at like diving into specific topics and kind of giving you a foundation. But then what you want to do is like go find problems and just kind of grind away and do a ton of problems, as many problems as you can, solve as many problems as you can. So this is one of the sites that we recommend for that we just kind of default to. There are a lot of good sites, and I might play around with some other ones as well at some point. But basically, after you sign up for Code Wars, you're going to see something like this. This is your dashboard. It'll take you here, and a lot of people will just go and do to whichever problem Code Wars is suggesting. What I like to do is, like you can use it however you want, but I always come out of my dashboard, and what I like to do is come to kata right here. So that's the magnifying glass icon right there. Excuse me. And in here, you can look for various challenges. Under my languages here, you'll just click here and scroll down and select Python if it's not selected. And then, yeah, now you can select a difficulty range. So the easiest problems are 8s and 7s, and the hardest problems are 1s and 2s. So it's a little bit backwards. If you're new to Code Wars, if you haven't used it before, a lot of people, myself included, when I first started, I used Code Wars partly to help me learn to code a number of years ago. And when I first started, I was trying the 1s and 2s, and I'll tell you, these are very difficult problems. They're tough. So I was like, man, I don't know if I can do this. So if you're looking at the 1s and 2s and you're like, wow, if these are the easy ones, I don't know what's in store for me. Don't worry about it. They're very much legitimately hard. So I think the 8s and the 7s are a great place to start. You tend to focus in on like one or two basic concepts maybe being used together, and the problem solving aspects are very light, which kind of allows you to focus on like correctly implementing syntax and kind of thinking through simple core concepts, core paradigms of programming. So I think these are a great place to start. You can never practice too many basics, so if you want to do 7s or 8s, you can just click on them. If you want to select a range of difficulties, like say if I wanted to do like 6s through 4s, I would just click on 6, and I'm just holding my mouse and dragging my cursor to select a number of these. Cool. And then difficulty. So I'm just going to select 8 through 7 here, or 8 through, oops, I want to do 8s through 7. And we'll just look at 8s through 7s. Cool. It looks like we do have a question. Somebody's asking a question in regards to the LeetCode question. I saw this question at this link. Just no idea about what it is. Any thoughts? Let's take a look at it. I don't even know. I think I made a LeetCode account a long time ago, and I was like, I'm going to use this. And then I just ended up doing other things, but probably won't be able to log in, but we'll see if it'll show me the question at least, and we can kind of play around with it from there. This is interesting. This does not look like Python. This looks like maybe a markup of some kind, or possibly assembly language, which is interesting. Let's kind of read through this. So this is saying, I know the text is probably really small coming through the stream, but I'll just read through this. So this question says, I recently got this question in a data engineering on-site interview for a position in Menlo Park, whatever. This was part of the data modeling / systems design, data modeling and systems design interview. The interviewer shared the below sampled data logs. Given the below sample data, a row M1 P1 start means machine 1 start process 1 at timestamp 2.984. So the goal is to design a table schema for the data to be used, and data scientist to query metrics such as process the max average ellipse time, and they can plot each process. To design a ETL in Python to load data to above data model table. Okay, so we're gonna make, looks like making a table and an ETL in Python. Okay, this is a really interesting question. I hate to say this. I would love to dig into this. For the purposes of stream, I think this is beyond the scope of what I intend to cover in stream. I apologize for that. I'd need to kind of look into this for a while, I think, and probably get back to you with a more thorough explanation outside of streaming hours. Yeah, it's a cool question. I'm going to keep this open, and maybe I'll touch base with you after we wrap up stream. But yeah, I do want to keep this more. I want to keep this kind of. And I apologize. I should probably be clear about this. Since this is affiliated with our prep program, sort of, I want to kind of keep it oriented around more core concepts relating to Python for now. But yeah, this is this is a really cool question. There's a bit going on there. Cool. Yeah, sure thing. Yeah, send me a DM if you don't mind. Direct message me on Slack, and then that'll, just say like, hey, reminder to look at this link or whatever, or just say hey or whatever, and I'll remember to get back to you. That'll help me get back to you quicker. Cool. Yeah, sorry about that. I should be a little clearer about the kind of the intended scope for the stream today, but yeah. All right. Cool. So I'm gonna get into some of these code wars problems, so you can look at this. I've got 8s and 7s selected, so I've got the kind of easy level problems selected. Excuse me. Okay. Let's see. There we go. Cool. So from here, I just like to, I don't know, I just kind of look for a problem. I judge the book by its cover. Honestly, I'm just like, it seems like an interesting title. I just wait for something to grab me, but looking for a benefactor, strange mathematics. I don't know, remove exclamation marks. So let's go over here. So you'll click on the problem that you want to try. It'll take you to this page. And oops. From here, you can kind of read about it. There's people commenting on it. There's different languages, whatever, similar questions, things like that. And then you just click train, and we'll go from here. So this just says write a function, remove exclamation marks, which removes all exclamation marks from a given string. Okay, so few ways we could do this. I chose this problem just based on the title. I figured we'd probably be removing exclamation marks. As much of a shocker as that is, right? Well, I'll just do it this way. Okay. But I chose this because I wanted a nice, simple problem, really to talk about the process, kind of the way that I go about using Code Wars, rather than getting stuck in like a complicated problem. We'll look at a more interesting, complicated problem as well. But even for a simple problem like this, I want to highlight a couple of approaches that we could take to solving this, and kind of talk about there's a bit of exploring we can do even with a nice simple problem like this. So when you come into Code Wars problem, you've got your instructions on the left here. You've got your area, the solution portion, which is the area for you to actually put your code. And then you've got your tests down here. And I just copied and pasted in those tests, and I'll talk about that in a second. So what I strongly recommend is to not do the work out of like the work of problem solving and coding, actual typing of your solution in the Code Wars environment. It's just not, to me, it's not really a complete environment. It's it doesn't have a proper terminal in the way that I'm used to, where I can print things out and run, kind of control the tests and run things the way that I'm used to. So, and it also doesn't have a lot of great like code completion features. The syntax highlighting is pretty good. It looks good, but it's kind of an incomplete tool in my opinion. If you're just starting out, we recommend that you start with Replit. REPL, I think it's Replit. Is it repl.it? It might be replit.com actually. But yeah, go to REPL. We have lots of links to it in our basic prep material, Replit, and that's a great, in-browser coding environment. It's not a tool that I would use like in the end, but it's a great place to get started. Ultimately, you will want to set up your own environment. Like I have my favorite text editor here that I like to work out of. So I'm going to work out of my text editor because that's where I'm comfortable. But yeah, just so long as you're working in what I would consider like a complete REPL environment, like VS Code or Replit, or maybe even Jupyter Notebook. Some people like to use like Jupyter Notebook or Google Colab is their primary coding environment. But whatever it is, just basically as long as it's not the Code Wars environment. So yeah, we'll just use this when we kind of finish our code in our environment, and then we'll paste it in and submit it. Cool. So like I said, you have the instructions on the left, the solution area on the right, and then below that you have tests. So this area I think is easy to ignore, and it's got a kind of a bunch of stuff in it that might feel a little like out of your reach at this time. And I know I just pasted a bunch of this in and kind of reformatted it, but I'm just going to chop this up and we'll kind of take a look at this, and it's not that scary. So let's back this up a little bit. So this is the way it pasted in, essentially, I think. Yeah. So this is the way it came from Code Wars here. So what I'm going to do is basically I'm just looking for any line that's going to make a call to my function here. So I look at this is the function that I'm going to be writing, remove exclamation marks, and the lines that contain that are the ones that I'm interested in. For now, I'm just going to stub out my function. We'll kind of flesh that out. So all this stuff, this imports the Code Wars testing suite of tools and kind of builds up some formal tests. And if you don't know what a test is, it's really simple. All that's required for a test is a call to the function or the class that you're testing, and the ability to capture that result. In this case, we're just passing it directly in. So the ability to look at what the thing you're testing is actually producing, what it's returning, or what state it's changing, whatever, and then some expectation for what that should give, right? So basically with functions, the way that's going to work is we have a call to our function, we pass in a specific input. And if we build our functions such that they will always give the same output given a set of inputs, then this kind of testing will work fine. If we don't build our functions that way, then we should probably think about building our functions that way, basically. So we should always be building functions that always give the same output for the same input, right? So there will be a parity between, you know, a given input and a given output every time, right? There are other paradigms that kind of don't do that do other things, but that's, I think at this point, you know, kind of canonically considered the correct way to do things. So we want to write our functions in that way. All right, cool. So you can see here, we're just calling the function, we'd be getting the output here, and then this is what we'd be expecting. So basically all I'm going to do is just wherever it says has these test.asserts, I'm just going to replace these with print. And this is just going to call my function. It's going to print out the result and the expectation. And if the result actually matches the expectation, then I know it's running correctly. So once I'm seeing the same thing in all of these twice, then I know it'll be running correctly. Whenever you're writing your own code, I do suggest, highly suggest, that you write at least one test as you're working. If it's easy to think of other tests, if other tests are obvious as you're working through your problem, put those down. If you have parts of, you know, an example solution that are given in a problem statement, either from Learn or Code Wars or wherever, where you have this sort of, you know, given, where part of the problem statement says, well, given a certain input, it should produce a certain output. You can turn that into a test, and I recommend that you do. Sometimes I think people want to just like jump in and start solving the problem. And that's fine. I get it. I want to do that too. I always am like, okay, I'm done writing tests, and when I want to like get in and start doing something. You know, just make sure you write at least one test, right? Take the time to write at least one test, and if you want to write more, then great. If not, that's okay too. But one test makes all the difference, at least one, right? So kind of a rule of thumb, like never work on a function that isn't being invoked, that doesn't have at least one test for it. And that does a couple of things. It makes you think through the problem first, kind of at least in a cursory way, maybe not necessarily think through how it's going to work, but think through what it does and what it has to do. And that keeps you focused and keeps you on track. The other thing it does is, since it's invoking the function, I can just run this code at any time and maybe print something out in here or do whatever if I need to test something else out. So it just makes working generally easier. So anyways. All right, so this will take in, let's start building this out. This is going to take in text. I'm just going to call it txt. I'm going to take note here that the problem here is calling this s. Usually that's not important. Usually you can call this whatever you want. But every now and again, if you're having weird errors, you might want to just keep those the same. Or if you don't want to like have to remember to anticipate that as a potential problem, just keep them the same. But I'm going to name it text because that's what I like to do. Okay, and then from here, so one thing I noticed about this problem is I can build this. I can build a solution for this as a pretty standard, simple accumulator. Now, there's an easier way to solve this problem that I can think of, but we'll start with this because I want to show, I want to plug the the importance and sort of the centrality of the accumulator pattern, right? So I'm going to write a really simple accumulator pattern. If you don't know what an accumulator pattern is, it's sometimes it's called sort of jokingly called like the everything algorithm, because it shows up in so many different places. It's not like this big key secret to the universe, mind blowing thing. But basically, what it is, the accumulator pattern, is we start with something that we're going to accumulate on. Almost always, that thing starts as empty. If it's a string or a list or a dictionary that we're accumulating on, it's going to start at empty almost always. Not always, but almost always. If it's a number, we would probably start it at 0. If it's a Boolean, we may need to start it at false or true. It kind of depends on the problem where we would need to start that Boolean value. And there are Boolean accumulators, or problems that we do think of as Boolean accumulators. So this accumulator pattern is going to be a string, and I'm going to concatenate the elements that are not parentheses. I'm just going to add all the elements in that aren't parentheses. So if an element is a parenthesis, I'm just going to skip adding it. If it isn't a parenthesis, then I'm going to add it in. And that's basically an example of the accumulator pattern. So we start with something empty, and then we repeat a process by iterating through some source of elements, or just repeating a process a certain number of times, right? So in this case, our source of elements is text, right? So the way I'm going to repeat the process is I'm going to say for. I'm going to write a for loop. I'm going to say for ch, which is short for character, for character in text. Oops. And then I'll say acc plus equals ch, and let's just test this out real quick. Oops, let me run my code. There we go. Cool. So if we look here, we've got hello world with exclamation points and hello world, right? So the result of my function is basically that it's copying the input. I'm accumulating every single character, including exclamation marks. So what I want to do is exclude exclamation marks. So what I'm going to say is if ch is not equal to exclamation mark, then I'll accumulate it. And so if this condition yields true, then it'll run this code. Oops. Then it'll run this code in the body here, acc plus equals ch. And if this condition is false, this condition will be false when ch is equal to an exclamation mark. So if ch is an exclamation mark, this condition is false, and we just don't do anything and go to the next iteration of the loop, right? So we'll try that, and you can look here, hello world, hello world, hello world, hello world, hi, hello, oh no, and oh no, right? So these look like they're duplicated appropriately. So it appears that my result is matching my expectation for the results in all of these cases. So let's just try this out. Oops. And we'll see. Sometimes they throw weird curveballs. Okay, it did pass. It passed all the tests. So once you're done, once you've found a working solution, you've written some tests and had it pass the tests, just paste in your code here. You don't need to paste in tests. Just paste in the function, or if you can have a helper function. If you have a helper function, you'll paste that in as well. Paste that in, and then you can hit test here, and it'll run these tests, or you can hit submit. Oh, excuse me. Let me just try this again real quick. You can hit test, and it'll run those tests, or you can click attempt, and it will run all of the main tests that are sort of behind the scenes that you can't see here, right? So there's a whole other bulk of tests. So you can see this is 1, 2, 3, 4, 5. There's 5 tests here, but then this says past 45 tests. So there's 45 more tests behind the scenes that we don't have access to, that we can't see. Um, most of the time, well, I don't even know. A good chunk of the time, actually, with the problem in Code Wars, if it passes all of these, it will probably also pass the other tests. But there's a pretty good chance, the way these questions tend to be able to be written, that it will pass the tests in here, but it won't pass all of the behind the scenes tests. This can be kind of an annoying feature, but it actually gives you the opportunity to practice something that's really important, I think, for like developing a good workflow in programming, which is anticipating test conditions, right? So I didn't do it for this one because I don't want to totally like dive all the way deep into like test driven development stuff, but you can pull in these tests, turn them into simple tests in here, or do whatever kind of testing you want. You can start, if you're new to test driven development and testing in general, you can just make these quick little unit tests like this with print. There's some variations on this that I'll do to give me a little more information sometimes, but this is a good place to start. And then it's always a good idea to kind of look through them and kind of make sure you understand them. Maybe even run them one at a time and make sure, if I look at this and I'm like, well, what is this gonna do? If I pass it nothing, I expect nothing, what's that mean? Well, you can see it's just gonna give me nothing. So that might not be that interesting, but now you know what it does. So you can kind of play around with them. And think about the tests and think, am I covering every valid case of, sort of category of input, right? Maybe I want to see how this is going to do if I put a question mark in it, right? So maybe I should have a test with a question mark in it, just to make sure that it's not deleting question marks, right? This one should have question mark there. So things like that. So you might think of like other things to test, or this is honestly kind of a bad example, but well, it's an okay example. You might write a test like that. So yeah. And then once you're done with all that, you hit submit, and you can go through. Yeah, you can go through here. And look at other people's solutions, right? So you can see there's some people that solved it much more elegantly than I did, but I wanted to show this accumulator pattern solution because even though it's not the most minimal, it's simple in the fact that accumulator patterns are like learning the accumulator pattern and how to like quickly turn a problem into an accumulator pattern solution is a pretty central skill, right? So the cool thing about this is, and I really recommend when you're especially when you're starting working on programming, get really good at the accumulator pattern. Practice it with every accumulator type, practice multiple accumulators in one loop, practice like nested loops and different kinds of problems. And like there's like the variations. This is a very simple, very, very simple kind of got just a little bit of everything in its kind of most primitive form. But accumulator patterns can get much more complicated, and they can come in just a very wide variety of forms. So I recommend like getting really comfortable with this pattern. And the cool thing is, as you're learning, you might not know every feature or every built-in method or every technique or whatever. But if you're really good at the accumulator pattern, a lot of times you can make it work. If there's a function that's built in or a library or something that you don't have familiarity with yet, you can build it. And the accumulator pattern will not solve all problems, but it'll solve a whole lot. And it has the ability to kind of fill in the gaps, right? So this isn't really quite what I would say like the right way to do this, but it works. So who cares, right? There's no shame in a working solution. So let's look at kind of a better solution. I could use the replace method. We'll do train again here. I could return text.replace. And let's just do exclamation with empty string. And there we go. So just this one line will do it. So strings have a method built in called replace. And replace takes in an element that may or may not be in the string. And let me just test this real quick. Yeah, okay. So the element doesn't have to be in the string, but if it is in the string, then it will replace that with whatever else you tell it to replace it with. So if I want to replace all the exclamation marks with hashes, I could do this. And this is going to replace all the exclamation marks with hashes. But I don't want to do that. I actually just want to replace it with an empty string, and that will just delete it. That has the effect of just removing it from the string, right? So it's important to note that replace will act on all occurrences of the first argument that appear in the string. So it'll replace all the occurrences, which is usually the behavior that you want. Replace is not a mutable method, right? So I can't do this. I can't say text.replace exclamation point with empty string and then return text, right? So strings in Python are immutable. If I try to run code like this, it will appear as if nothing happened. So the replace method does not mutate. It does not change the value of text. What it does is it performs a transform, which just means it returns that value without altering the value you called it on, right? So it doesn't alter the text. It just gives you back a version of it, right? So this expression, text.replace exclamation mark with empty string, literally expresses the correct result, right? So since it expresses the result that I want, I can just return it. Or I could capture it in a variable like res for result equals text.replace, and then we could return res. But since that's sort of an extra step, we can just also return res like that, or return text.replace like that, and that'll work as well. So let's just try that. Oops. There it is. There we go. So that works, and we'll hit submit. Great. All right. Cool. All right, so let's maybe, I think we could got time. We could got time for one more. I was gonna try to correct myself for saying could got, but I don't know. I think it makes sense, so I'm gonna go with it. So let's maybe do a 6. Optional walrus. Okay, I'm interested. Optional walrus. It made me laugh. I don't know why. It just sounds silly. Interesting. rewrite this function below so that it is 31 characters or less. What? Okay. That's the weirdest criteria uh, for a solution that I've heard. This is just silly. This is great. Um, so I think my goal is going to be to do this in as few characters as possible. Um, so let's just see. So I just wonder what it does. So f takes in an iterable and an integer. Um, it takes the length of the iterable, and it says if length is greater than integer, return length, else return 0. Okay, cool. What a wonderfully silly thing this is. It's really funny to me. I'm gonna Slack this to myself because I want to share this with a coworker. This is a really funny challenge. Okay, let's see if I can remember how to use Slack really quick. Basic computer usage skills activate. Okay, good. So okay, same thing here. I'm just going to convert these. Okay, so my goal now is to just get this as small as possible. So one thing right out of the gate, we can get rid of a return by turning this into a ternary. And we'll do this. So this is how we can turn this into a ternary. It's our return. We can get rid of a length as a whole thing and replace that with that. So I think logically speaking, this is as much as we can reduce the size. Okay, so we probably have to rename everything, and it looks like, what is this? This is, I think, 74 characters wide right now. So yeah, we have to rename things to make them smaller, right? So we can't rename the keywords, but we could rename these. So iterable, another synonym for iterable that I will use is collection. So we'll call that C. Integer. Oops. Well, let's see here. Oh yeah, okay. Let's do this. Here, I made, because I just realized length here shows up twice. I'm being silly. So let's call length, let's call this L. Oops. Shows up 3 times. What am I talking about? Oh, I mean twice in here. Gosh, confusing myself. Okay. And then we'll rename iterable to be C for collection, and we'll rename integer to be I. Gosh, I don't think this is going to be less than 31 characters. Let's see. This might actually pose somewhat of a challenge. Okay, so this is going to be 29. Nope, that's not going to do it. Okay. And I think it'll be, let's just try this. I'm just going to try it. We'll just see what happens. Okay, code size should be at most 31 characters. So I'm at 56 characters, and that's after a lot of trimming. All right, well, let's see then. Perhaps, could I save space with a lambda? This is actually a really interesting problem. So could I save space with a lambda? So if I said f, oh my gosh, and am I gonna, if I had to do, yeah, we'll have to minify this. This is the oddest constraint I've ever had in a Code Wars problem. I'm having a lot of fun if you can't tell. Okay, so I'm down to 51 characters. All right. I'm thinking maybe this might be the smallest it could be. It's 31. Okay, so we'll say f equals this. We'll take in that and that, and we'll say this, but I can't make an assignment like this. So I would have to use len twice. We'll just try this. We'll see how close this gets us, if it gets us anywhere. So we'll say this. I don't think it's going to be right. 39. Wow. All right. 39. So we've got 8 characters to go. Probably something really obvious that I'm missing. We're at 39. Okay. So maybe the solution is to just go fully branchless here. So if we take, oops, I can delete a character there. So that'll give us 38. So we have 7 to go. And then if I go fully branchless here, what's that going to look like? So len c. Oh. Oh. Right. This is going to return if len c is greater than I. Yeah. I was thinking maybe we could use max. But if we return I, and also what if they're equal? That's a very interesting one. And I don't see any of the tests where they're equal, actually. Yeah, they're always unequal. So that kind of tells me, because I think if I try to use max 3 and 3, I think this is going to give me an error. No, it doesn't. It just gives me 3. Well, I feel silly now because it seems obvious, but you know, hey. Okay, so if I did, what if I did, I just have a hunch here, like max of len. I've got to do this. Max of len c and I. Try that. Hindsight's 2020. Yeah, right. But that's, I don't know. That's part of the course. I'm like, I don't think it works. That, oh no, it does work that way. Yep, I was wrong. Happens all the time. You know, important thing is just being able to test it, right? Cool. Okay, so if I did it, let's see. If I did this, this isn't gonna give me the right answer. See, that's the problem with that, is it's gonna give me the wrong answer. And you can see here, so if length is not greater, I want to return 0. I don't want to return, I wonder, does it count if yeah, okay, so I can't add code. It's the whole size of the entire code has to be smaller than that. We don't have a regular ternary. No, we don't. F equals lambda. That's going to mess that up. It's like this. I don't think I can have like I want to have something like, I'm thinking about like if I had L equals len c, then I could just do L here for len, and that would save me something. But it wouldn't actually save me enough, because that's still 36. Holy cow. Okay, well, I can't do that anyways because I can't make an assignment in a lambda like that. Wow, I wonder if I've got to do something like totally kind of out there. Let's try this. Def F. This is going to be longer. Yeah, that's going to be longer. Okay. So, I feel like the answer is somewhere in here. The answer lies somewhere in here. I've got to totally change the way that that's going to work. Okay. So this simple function takes an input iterable integer if the length of the iterable is larger than the integer, it returns that length. Otherwise, it returns 0. All inputs will be valid, and all iterables will have a defined length. Okay. Okay. Well, let's see. 28. So that's my Oh my gosh. um, I have 2 characters to spare here. Okay, let's see here. Nope. Okay, I have 3 characters. Wow. Oh, no, and I'm wasting one. I'm wasting a perfectly good character right there. So I've got, if I take this solution, I've got, let's do this. I'm just going to make myself a little measuring tool so I know how many characters I have to stay within. Wow, that's tiny. Okay. Um, that is a challenge. So I think this is kind of getting into branchless programming because I can't even use a ternary or a traditional condition. Those are too long. So, yeah, I think this is getting into there's some branchless programming concept, which is always something that I've kind of intentionally ignored because I find it silly. I'm like, are you really trying to save that many characters? And right now I am. I am totally trying to save that many characters. So, yeah, I wonder maybe what if I did map? Huh. If I mapped Len, but I can't map Len, I could map um, the length of C is greater than I, return length of C, else return 0. I am legitimately stumped on this one. This one's fun though. Um, if you've got if anybody in chat has an idea, uh, just something you want me to try, feel free to put it in there. Man, I am like, how do you get that in less than, oops. How do you get that in less than 31 characters? That is tricky indeed. It seems so simple too. That's a good problem. I wonder. Wow. Okay, so this this code has been completed 120 times. So that's not that many people. So it looks like it's a fairly new challenge, recently written. So, but it is. I mean, 50 people did it, or excuse me, 100 people did it. 50 people commented on it. 100 people did it. Wow. Okay. 31 characters. So if I did max of the length, you missed the setup. So the setup is here. I'll post the thing in here, right? So it's write the following code in 31 characters or less. Write a function that does the same thing in 31 characters or less. The funny thing is, this is not a hard problem. Like there's no logic to be solved here, but it's just it's like the challenge is literally to get it in a as few characters as possible, which is a kind of a silly but very interesting challenge. Yeah. So I'm thinking about like how to. I wonder like if I. It seems like I have to do some sort of. I have to. I have to develop like a closed formula. I think for this, right? So something that like will cancel out the I. So if I did, I don't know. I don't know. I wonder. I wonder if I just did this. Ugh. Hmm. It's not gonna do it. It's not gonna do it. Wow, what an interesting problem. All right, well, um, we got 3 more minutes. Wow is right. I'm in definite wow mode right now. We got 3 more minutes, and then if I don't get it in that time, I'm gonna wrap up stream. I'm gonna admit defeat. I'm gonna accept my limitations, and I will post a solution after stream, which will probably be like 2 minutes after stream. And but yeah. Hmm. I was like going through everything. If I divide this, if I um, min, max, multiply. Gosh, there's got to be some obvious operation here. I really want to do a ternary. That'd make this so freaking easy if I could just use that ternary. Okay. Let's revisit this. I think this is probably not going to work. So let's see if I can't do. Could do that. Could I do this? I can't. Hmm. Okay, time to jump into the old terminal here. Okay, so if I do hmm hmm interesting. This I may be onto something. I floor divided by C. Okay, so that give me zeros in the right places, but it's not going to give me C in the right places. And this is going to be len C. Okay. Oh, that's interesting. This gives me zeros in exactly the wrong places. Wait, what? Is it just, no. Is that it? Interesting. Very interesting. So these should give me zeros. This one is equal. That's interesting. And it should give me 0 because this is not greater than. Ooh. 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 +1. Should we adjust for that? We could correct for that. Okay, so I'm getting. What, does this work? 3, 3, 40, 45, 5. No, it doesn't work. 3 and 3 when I want zeros. Oof. Oh, I feel like I'm onto something. But, one can feel like they're onto something and be onto nothing. So I am shooting in the dark. That's weirdly close, though. The funny thing is, I thought I was going to get these to pass, not these ones. um, yeah. That does work for that. Dang. So how do I get it to give me zeros when I is smaller? Let's just look at these. So, or when not when I is smaller, when I is greater or equal. Oh, so that does make sense. I was thinking, just had it in my head in a weird way. Okay, so 3 and 2. So 3 is greater than 2. So we get 3. Good. Right. So that does actually work like I'd expected. Okay. So the question is, we're back to max, aren't we? Okay. Well, that's slightly shorter. That is slightly shorter than max. Okay, so that's an improvement. And then in these cases, I expect 0 because I is greater, but I'm getting 3 in either case. So we've got 3 over 3 plus 1 is 4. 4 over 10 is that right? 4 over 10 is 0. And this says, okay, so the length of this, well, that's just weird. So the length of this does this need to be in parentheses? Is that what that needs? Oh. Okay, well that does that does fix that one problem. Okay, let's try that. Okay, cool. I think I'm gonna wrap it up there. This is a really interesting problem. I'm having a lot of fun with this. It's nice to get stumped on something every now and again. I feel like that's how you know you're being challenged and learning. This is, I've got to say, I didn't expect this. I thought this title was funny, but this is undoubtedly the weirdest code wordist problem I've ever seen. I've never seen a criteria for a problem be the length of the code in order to solve the problem. So I'm going to have fun with this one. I might chew on it for a little while. I will post a solution um, once I find one. If you find one, go ahead. Feel free to post a solution. I'm not going to look at for spoilers, but I'll at this channel when I find one. Hopefully everybody had fun watching me get stumped on this problem. Yeah, and I think that's, I want to kind of normalize this a little bit. Like we're all going to find problems that stump us. I have to admit to being a little embarrassed that I got stumped by a 6. But this is this is a very abnormal 6. I think the like once I see the answer, it's going to be very obvious. But this is a kind of coding, a way of prioritizing like space, the actual size of the code that I often code in a way that's like pretty explicitly counter to that, right? I let my code kind of expand out. So this is an area that I have pretty much deliberately ignored, but it is fun nonetheless. And yeah, uh, certainly, as you all are learning Python, you'll have times when you'll get stumped on things, and that's okay. Like let that be okay. I'm getting stumped on things. Um, you'll see us make mistakes and get stuck on things that are um, challenging. So yeah, anyways, hope everybody had fun. I look forward to doing the next one. Next one will be on Wednesday. We've got another premium prep starting today, this evening. Tovio and I will be leading that. If you're in that, I'll see you then. I look forward to working with y'all in there and working with you later in study halls. Do feel free to reach out if you've got any questions. Feel free to send me a DM on Slack, and I'll get back to you as soon as possible. So yeah, I'll wrap it up there. You all have a great rest of your evening. Bye bye.